It begins as a question that bends reality itself. What lies inside a wormhole? In the silence between galaxies, where gravity sculpts the shape of time, physicists have long imagined tunnels piercing through the fabric of the cosmos, gateways that could connect distant corners of existence in a single impossible breath. A wormhole is not a hole at all, but a bridge, a tunnel carved into the unseen geometry of space-time, where every point could be folded until far becomes near and the unreachable becomes one step away. The equations of Einstein's relativity whisper that such shortcuts are possible, curvatures so extreme that even light might choose the long way around. Yet, for all their beauty, wormholes exist only on paper, hidden inside mathematics that shiver on the edge of imagination. Still, we wonder, if such a passage were real, if we could slip past the horizon and drift through the tunnel's heart, what would we see? Would the stars stretch into ribbons, their light bending like liquid glass around us? Would time itself dissolve, unspooling into something we could touch? Or would every atom of our being be torn apart by tidal forces beyond reason, our journey ending before it ever truly began? Science offers equations. Imagination supplies the rest. To peer inside a wormhole is to step into the most forbidden of mirrors, one that reflects not just the universe, but the limits of what the human mind dares to know. Every theory of reality begins to fracture at its edge. Every definition of inside loses meaning when space itself becomes fluid. And yet, the question remains, glowing like a beacon in the dark. To find out what's within a wormhole, we may have to risk never coming back. It began with an idea that refused to obey the limits of space. In 1935, two men stared into the equations of general relativity and found something extraordinary hiding there. Albert Einstein and Nathan Rosen were not searching for science fiction. They were searching for consistency. General relativity described gravity not as a force, but as the curvature of space-time itself, a smooth and flexible fabric woven from geometry. Yet when they studied its equations around the most extreme objects, singularities, points where matter becomes infinitely dense, they discovered that space-time could do something shocking. It could fold. It could connect two distant points through a single continuous tunnel. They called it a bridge, an Einstein-Rosen bridge. On paper, it was perfect symmetry. Two black holes connected by a throat, a tunnel invisible to light, threading through the heart of space-time itself. To enter one mouth would be to emerge from the other. But the bridge had a cruel flaw. The equations that created it also destroyed it. Any attempt to cross would cause the tunnel to collapse instantly. No traveler, no photon, could make it through. Relativity had built a door that forever slammed shut. Still, the image lingered. This idea that the universe could fold back on itself, that perhaps distance was an illusion, and the farthest galaxies might be only a curve away. Decades passed, and others dared to push the idea further. John Wheeler, a physicist known for coining the word black hole, began to imagine space-time as a restless sea of foam. Beneath the calm surface of the cosmos, at scales far smaller than atoms, reality might flicker and froth with tiny wormholes popping in and out of existence, micro-bridges, connecting the universe to itself. This vision, quantum foam, suggested that wormholes were not just theoretical curiosities but inevitable consequences of a turbulent universe. Yet they would be unimaginably small, far tinier than a proton, and vanish before anything could pass through. Still, if nature could make them, could it make them bigger? Could a cosmic-scale wormhole survive long enough for light, or even a spacecraft, to cross? General relativity offered no comfort. To keep a wormhole open, one would need something the universe seemed to forbid: negative energy or exotic matter, capable of bending space-time in the opposite direction of normal gravity. Such matter would repel rather than attract, holding the throat of the wormhole open against collapse. The equations allowed it. Reality did not seem to. The cosmos appeared to mock our ambition, promising infinite shortcuts, yet demanding impossible materials to build them. But then came quantum mechanics, the lawless sibling of relativity. Where Einstein's universe was smooth, quantum theory's was restless, filled with uncertainty, probabilities, and strange symmetries. Quantum fields, according to modern physics, constantly fluctuate between existence and non-existence. Even the emptiest vacuum is alive with energy, and from that energy could come brief flashes of the impossible, tiny wormholes flickering in and out like bubbles on the edge of being. Physicists began to wonder, could the chaos of the quantum world stabilize what relativity forbade? Could a wormhole be held open by the ghostly fluctuations of space-time itself? In 1988, Kip Thorne and his colleagues explored this idea seriously, motivated not by theory, but by curiosity, and perhaps a touch of science fiction. Thorne was asked by his friend, the writer Carl Sagan, to find a scientifically plausible way for a human to travel across the galaxy for his novel Contact. The answer, Thorne realized, lay in the mathematics of wormholes. With exotic matter, energy with negative pressure, the tunnel could theoretically stay open. Traversable wormholes were no longer purely fantasy. They were mathematically allowed. The equations were intoxicating, but they also led to paradox. A traversable wormhole could, in principle, become a time machine. If one mouth were accelerated to near light speed or placed in a different gravitational field, time would pass differently for each end. Step through, and you might emerge not only elsewhere, but elsewhen. The universe, through pure geometry, could break causality. You could meet your own past, alter your own future, and unravel the logical fabric of reality itself. Physicists debated fiercely. Some argued that quantum effects, so-called chronology protection, would destroy such wormholes before they could create paradoxes. Others believed the universe might tolerate them, as long as no observer could exploit the loop. In this strange dance between mathematics and meaning, the wormhole became more than a tunnel. It became a mirror reflecting the contradictions of our own theories. Relativity and quantum mechanics, the twin pillars of modern physics, could describe the universe beautifully on their own. But together, they tore each other apart. And somewhere in that conflict, the secret of wormholes might be hiding. Even the name black hole carries echoes of this mystery. For most of human history, black holes were feared as the ultimate dead ends, cosmic graves where light, time, and information vanished forever. But modern physics has slowly rewritten that myth. The event horizon, once thought to be a one-way boundary, may hide deeper structures inside. Some theories suggest that a black hole's singularity could connect to a white hole, a theoretical opposite that expels matter instead of swallowing it. If such a pair were connected, the bridge between them would be a wormhole. The most terrifying object in the universe might secretly be a doorway. And yet, no one knows what lies beyond that horizon. The mathematics of general relativity breaks down inside it. The rules that govern space and time stop working. What begins as geometry ends as silence. We can only imagine what happens when matter crosses that threshold. Whether it's crushed to nothing, reborn in another universe, or scattered into the quantum sea. Every answer defies logic. Every theory bends under the weight of the unknown. The paradox deepens when we realize that wormholes are both everywhere and nowhere. If quantum foam is real, the universe might be filled with microscopic tunnels connecting every point in existence. You, the viewer, might be separated from a distant galaxy not by trillions of miles but by a quantum heartbeat. A hidden fold in space-time so small we can never touch it. The universe may already be unified beneath its apparent distances, its vastness an illusion drawn on the surface of a deeper, invisible structure. And yet, to open a macroscopic wormhole, to create one large enough for travel, would require energies beyond comprehension. Some calculations suggest you'd need as much negative energy as an entire star produces in its lifetime, precisely arranged to stabilize the throat. Others propose that advanced civilizations, if they exist, might harness dark energy itself to sculpt space-time into bridges. In that case, the distant lights we see in the night sky might not be unreachable worlds, but invitations from those who learn to walk the hidden paths between them. But here lies the heart of the philosophical paradox. The very act of imagining a wormhole forces us to question what space is. We think of distance as something real, measurable, absolute. Yet in the mathematics of relativity, distance is not a property of the universe. It is a relationship, a curvature, a way in which events are connected. A wormhole simply exposes that relationship in its most extreme form. It says, the shortest path between 2 points might not be a line, but a fold. And that idea, simple yet cosmic, echoes far beyond physics. It suggests that the universe itself might not be built on separation, but on connection. Every galaxy, every atom, every moment might already be entangled with every other. What we call distance could be only the illusion of not yet understanding the whole. The bridge, then, is not just mathematical, it is existential. When Einstein and Rosen wrote their paper in 1935, they likely never imagined how far their thought experiment would reach. Yet their equations, born from the desire to understand gravity, became the seed of a new cosmic mythology, a story of tunnels through reality, of shortcuts through infinity. Decades later, as quantum gravity tries to unify relativity with the quantum world, wormholes remain at the crossroads of everything we don't yet understand. String theory proposes that the universe's basic ingredients are not particles but tiny, vibrating strings, and within its multidimensional geometry, wormholes appear naturally as the threads connecting distant regions of the cosmic fabric. The holographic principle, another frontier of theoretical physics, goes even further. It hints that wormholes might be nothing more than the shadows of quantum entanglement, that every pair of entangled particles is connected by a microscopic wormhole. The universe, seen this way, is not a vast expanse, but a web of invisible bridges, each thread a connection between minds, moments, and matter. It's an elegant thought that what Einstein once called spooky action at a distance might be the same as what we now call a wormhole, that love, gravity, and information all obey the same hidden symmetry, binding what appears separate into one coherent whole. And yet, this vision leaves us humbled, because every step forward only deepens the mystery. Every equation that predicts a bridge demands a price: exotic matter, impossible energies, or paradoxes that threaten causality itself. We can write the mathematics of connection, but we cannot yet live it. We can imagine the crossing, but not survive it. The question of what's inside a wormhole is not only about physics, it's about limits. The limits of knowledge, of imagination, of existence itself. Perhaps the bridge exists, waiting in the folds of space-time, patient as the universe's own reflection. Or perhaps it is nothing more than the shape our longing takes when we dream of escape. From distance, from time, from mortality. The universe may allow wormholes. It may even create them. But to pass through one might mean confronting not only the laws of nature, but the nature of reality itself. A wormhole does not just connect 2 points in space. It connects the possible and the impossible, the known and the unknowable. And maybe, somewhere in that impossible fold, the universe keeps its most dangerous secret, that there is no real boundary between here and there. Only the thin veil of what we have yet to understand. Imagine you are standing at the edge of a star that isn't a star, staring into an opening that should not exist. No horizon, no surface, just a darkness so absolute it seems to pull not only light, but meaning itself inward. The air, or what remains of it, vibrates with gravity. Around you, space is no longer a backdrop, but an actor, bending and twisting, folding in on itself like molten glass. Somewhere ahead lies the entrance, the mouth of the wormhole, a silent promise, or perhaps a trap, waiting to see which you'll choose to believe. From this distance, it appears almost peaceful, a shimmering disk suspended in the void, light curving around its edges like liquid mercury. But it is not peace you feel, it is surrender. Every photon that grazes that boundary is swallowed whole, stretched thinner than thought, until its frequency climbs beyond existence. To approach this mouth is to approach an argument between creation and annihilation, between geometry and chaos. As you draw closer, the stars begin to behave strangely. They stretch and twist, their patterns dissolving into concentric rings. The light behind you bends forward, wrapping around your ship, until every direction becomes forward. The universe begins to funnel. This is not motion as you know it. It is falling without falling, acceleration without speed. Space-time itself is moving beneath you, carrying you downward into a gradient that grows infinitely steep. Relativity predicts that near such a throat, time itself warps like a rubber sheet. To an outside observer, your descent would appear to slow, drag, and finally freeze. They would see you hover forever on the brink, locked in a single instant of hesitation. But from within, you would feel no pause. The fall would continue, inexorable and smooth, as clocks on your ship tick normally. In this way, the wormhole begins its first trick. The closer you get, the slower you seem. The nearer you come, the farther you become. Your instruments fail to agree. Gravity is not merely strong here, it is distorted. The equations of general relativity predict an almost unbearable gradient of force. A stretching and squeezing so intense, it's been nicknamed spaghettification. In a normal black hole, this is the end. You are torn apart, atom by atom, your molecules elongated across kilometers. But a traversable wormhole, if such a thing could exist, must cheat these rules. It would require a substance of unimaginable strangeness, exotic matter, to resist collapse. Exotic matter is not antimatter, nor any known form of substance. It is energy that bends space in reverse. Where normal matter attracts, this repels. Where mass curves space-time inward, exotic matter pushes outward, holding the throat open like invisible scaffolding. Without it, the tunnel would pinch closed faster than light could escape. With it, the geometry of doom becomes the geometry of passage. But this miracle has a price. Exotic matter violates the classical energy conditions of relativity. Its negative energy density means that, in some frames, it appears to subtract from reality itself. It doesn't simply exist, it unexists. Such matter has never been found, though quantum mechanics hints at its shadow. In the Casimir effect, when two metal plates are placed extremely close together, the quantum fluctuations between them are restricted, producing a measurable negative energy, tiny, fleeting, and weak. But proof that the universe can, in principle, produce something that defies gravity's grip. To hold a wormhole open, you would need such negative energy on a scale comparable to the mass of entire planets, woven into the structure like an unseen skeleton. And so, the paradox grows. The laws of physics that allow the wormhole's existence also conspire to destroy it. Yet, somewhere between those contradictions lies a path, a razor-thin equilibrium between collapse and defiance. If the throat can be stabilized, if the exotic matter can resist the crushing inward pull, you might survive the descent. But survival is a generous term. What you experience next may not resemble life as you've known it. The first thing to break is your intuition. Inside the throat, distance loses meaning. You no longer travel through space. Space travels through you. The walls of reality fold and ripple, forming an impossible corridor where forward is backward, and motion becomes a question of perspective. You might look out a window and see your own image falling toward you from ahead, delayed by warped light. The photons leaving your face could circle the throat and strike you from behind, showing you what you looked like seconds ago. Every direction begins to collapse into one. Time, too, becomes unstable. Relativity teaches that in strong gravitational fields, time dilates. It slows relative to weaker fields. Near the throat, this effect grows monstrous. Every second you experience could be a century outside. Stars could be born, blaze, and die while you are still crossing the distance between two breaths. To fall through such a place is to become a ghost in history, living out eternity in a heartbeat. And yet, there is another paradox. From inside, time might not just slow. It might reverse. The equations that govern the interior of a wormhole allow for regions where time behaves as a spatial dimension, and motion through it could send signals backward relative to the external universe. To an outside observer, you could emerge before you entered. Cause could chase effect in endless circles. To navigate such a geometry would be like swimming through a dream where every ripple flows both ways. You feel it before you understand it. The ship's lights stretch ahead, their reflections lingering in impossible curves. Clocks begin to stutter, electronic signals loop, data packets repeating fragments of themselves as though trapped in echo chambers of time. Each moment feels pregnant with another moment, each instant folding into its twin. You realize that what you call before and after are not separate here. They coexist, layered like the pages of a book written all at once. The deeper you fall, the quieter it becomes. Radiation thins out, particles vanish, and the universe outside blurs into a single pale glow. The sound of your own heartbeat seems to stretch, drawn out until it resembles a slow drum echoing across centuries. The wormhole's throat is not dark. It is luminous, but not with light as you know it. It glows with curvature itself, space-time shining under its own tension. Every direction leads inward, yet none seem to end. Your mind rebels. For the first time, you confront what Einstein called the incompleteness of intuition. The brain evolved for Earth, for apples falling, for sunlight bending through air, not for the geometry of infinity. Here, up and down dissolve, near and far overlap, cause and consequence dance in perfect symmetry. You are not moving through space. You are being rewritten by it. Perhaps this is what the universe looks like from the inside of a thought. For what is a wormhole if not an idea made real, a piece of imagination sustained by mathematics? You begin to understand why physicists speak of them with reverence. They are not simply structures. They are contradictions, places where reality tests its own boundaries. In that sense, entering a wormhole is not a voyage through space, but through meaning. But the science remains merciless. Every model we know predicts instability. Even the slightest disturbance, a photon, a breath, a passing wave of radiation, could trigger collapse. The tunnel could pinch shut before you reach the other side, crushing you between converging infinities. To survive, the wormhole must be perfectly symmetrical, perfectly balanced. One atom of imbalance, and the geometry tears itself apart. And yet, physicists persist in imagining. Simulations show that if exotic matter can be arranged just so, the throat can remain open indefinitely. The shape resembles a catenary, like the curve of a hanging chain, draped through the higher dimensions of space-time. To pass through it would be to slip along a line of least resistance, a path carved through geometry itself. In some models, the interior might feel eerily calm, free from tidal forces, as if gravity had been neutralized. You could float weightless, surrounded by the glow of warped starlight, hearing nothing but the hum of space-time itself. Others predict a far more violent crossing. Near the edges, the curvature could oscillate wildly, compressing and stretching time like a wave. You could witness the entire future history of the universe in a flash, or the past unraveling before your eyes. The wormhole, in such a vision, is not a highway, but a crucible, burning away everything that enters until only information remains. The closer you approach the midpoint, the true throat, the more physics blurs into philosophy. What does it mean to cross a place where distance no longer exists? What does it mean to arrive when every point of space is superimposed? In the heart of the wormhole, you might not move at all. You might simply exchange identities with another part of the universe, the way a reflection replaces its source when you look into a mirror. You may not travel. You may trade places. And that is the final paradox. To enter the wormhole's throat is to surrender the very concept of being in one place rather than another. The journey becomes a transformation, a dissolution of individuality into the curvature of existence. Every molecule, every photon, every bit of information that once defined you becomes part of a larger symmetry. In a sense, you are no longer falling. You are being woven into the fabric of the bridge itself. Then, perhaps, a flash. The geometry stabilizes, the curvature relaxes, and light, once stretched beyond recognition, contracts again into coherence. You glimpse a shimmer ahead, a horizon of possibility. Whether it's an exit or extinction, no one can say. For those who fall into a wormhole, there may be no distinction between arrival and erasure. Maybe that's the point. Maybe a wormhole is not a tunnel between two worlds, but a reflection of the universe upon itself. A cosmic heartbeat where everything folds inward to remember what it is. The descent is not destruction, but revelation. The point where space, time, and consciousness overlap and reveal their unity. If you could see yourself from the outside now, you would appear frozen on the brink, forever falling, never gone. But inside, where you truly are, the journey continues, deeper and deeper into the geometry of the impossible. The light bends backward. The echoes arrive before their sources, and time itself, at last, forgets which direction it was meant to flow. What kind of mind dares to build the impossible? To not just dream of walking between stars, but to sculpt the universe itself into a doorway? The question echoes through every equation, every theory that brushes against the edge of wormhole physics. If such tunnels through space-time can exist, then perhaps they can also be made. And if they can be made, then perhaps they have already been made, by hands or intelligences older, stranger, and far more patient than our own. But first, we must understand what building such a thing truly means. A wormhole is not a structure in any normal sense. It has no walls, no floor, no fixed coordinates. It is geometry itself bent into a loop, space-time made fluid, sculpted to form a bridge between two distant regions. To construct one is to edit the operating system of the universe, to rewrite the rules of distance and causality. In Einstein's equations, wormholes arise naturally under the right conditions. Enough mass, enough curvature, and the proper mathematical symmetry. But to hold one open requires something far more elusive: negative energy. This is not just a deficit of energy, it's a reversal of its nature. It pushes where everything else pulls. It stretches where everything else collapses. It is the anti-gravity of imagination made real. No known material behaves this way. The exotic matter required would have to possess negative mass or negative pressure, properties forbidden by classical physics. But the quantum world, as always, complicates the story. Quantum field theory allows for fluctuations in energy density, regions where the vacuum itself dips below zero for brief moments. The Casimir effect demonstrates this. When two plates are placed nanometers apart, they experience an attractive force, as virtual particles are suppressed between them. The vacuum between becomes less than nothing. Some theorists suggest that with enough control, enough precision, a civilization might amplify this phenomenon. Arrays of quantum fields, carefully tuned, could produce macroscopic regions of negative energy. It would not be easy. It would demand energies rivaling the output of stars and stability beyond any known engineering. Yet physics does not explicitly forbid it. The door is not locked. It is merely buried beneath the hardest mathematics ever written. This is where imagination collides with ambition. In the 1980s, Kip Thorne and his colleagues at Caltech explored the physics of traversable wormholes seriously for the first time. Not as fantasy, but as equations. Their work, inspired by Carl Sagan's request for a scientifically plausible interstellar travel mechanism in contact, produced something astonishing. If negative energy could be stabilized, if space-time could be precisely shaped, then not only could a wormhole exist, it could be traversable, even safe. The thought changed everything. For the first time, the impossible had blueprints. They were incomplete, yes, written in mathematical language rather than steel or plasma, but they existed. Wormhole physics, once a poetic metaphor, became a frontier of speculative engineering. Imagine what such a civilization would need to do. First, they'd need to create or locate a black hole pair, two singularities that could serve as the mouths of a potential bridge. This could be achieved through controlled collapse, feeding a dying star with additional mass until it implodes, but shaping its rotation, charge, and magnetic field to precise parameters. Next, they'd have to manipulate quantum fields around those singularities, injecting negative energy to prevent the throats from collapsing. The result would be a balanced, pulsating conduit, a self-sustaining structure where curvature holds curvature in check. At this scale, the tools of construction are not cranes or machines, but gravitational waves, magnetic fields, and quantum feedback loops. Imagine Dyson sphere-sized rings orbiting a black hole, channeling starlight through superconducting lattices to sculpt the local geometry. The ring becomes a lens, bending energy until space-time folds upon itself like a crease in silk. At its center, a shimmering hole, humming with the tension of the universe, trying not to tear. Simulations have tried to imagine this process. Physicists like Matt Visser, Kip Thorne, and later theoretical engineers proposed stabilization models using scalar fields, exotic energy distributions that could counteract gravitational collapse. The equations suggest that, under certain conditions, a wormhole could remain open indefinitely. But the margin between stability and destruction is thinner than a proton. One fluctuation, one misplaced quantum pulse, and the entire bridge implodes into a singularity, releasing its stored energy as a burst more powerful than a supernova. The builders, then, would need to operate with godlike precision. They would need to anticipate not just the motion of matter, but the dance of probabilities. Their technology would blur the line between engineering and prophecy, predicting the fluctuations of space-time before they occur. In their hands, the quantum vacuum becomes a canvas, gravity a brush, light a tool for sculpting existence itself. Would they attempt it? That's the philosophical question that lingers behind the math. What kind of intelligence would risk building a door with no guarantee of an exit? Humanity is reckless enough to try. History is littered with examples: machines that could explode, reactors that could melt, accelerators that could tear apart the atom's heart. We build first and ponder later. But for a civilization advanced enough to manipulate space-time, perhaps wisdom has caught up with power. They would know the cost. They would know that a wormhole, once opened, cannot easily be contained. If its throat collapses, it could unleash energies capable of sterilizing entire systems. If it remains open, it could link realities with incompatible physical laws, bleeding one universe into another. The bridge could become a wound, and yet, perhaps curiosity wins. Perhaps somewhere in the cold heart of the cosmos, a civilization decided the risk was worth it. Maybe they found a way to anchor the mouth of a wormhole using cosmic strings, infinitesimally thin filaments of immense density left over from the early universe. These relics, if they exist, would carry gravitational tension so great that even space-time bows before them. Two cosmic strings, looped and crossed, could theoretically stabilize a wormhole, holding its throat open like the chords of a celestial harp. If such beings exist, their engineering would not be visible in the way ours is. We might not see their cities or ships. We might only detect their footprints in physics, regions of space where gravity behaves strangely, where light bends without cause, where time seems to lag behind itself. Some anomalies observed near supermassive black holes, odd jets of energy, distortions in radio waves have already sparked whispers of artificial geometry. Not proof, but hints. Suppose, then, that wormholes are not rare accidents, but ancient architecture, remnants of civilizations that learned to mold space-time long before we learned to split atoms. They may not have survived the act of creation, or perhaps they transcended the need for survival altogether, living now as patterns of information flowing eternally through their own bridges. What we call wormholes might be their monuments, their cathedrals, tunnels left humming in the dark long after their builders vanished. Philosophically, this leads to a terrifying symmetry. Every tool capable of connection is also capable of destruction. Every bridge is a potential abyss. To open a wormhole is to challenge the boundary between universe and non-universe, between causality and chaos. The builders of the impossible must not only master physics, they must master restraint. There's another possibility, one both humbling and exhilarating. Maybe we ourselves are already part of a structure built by something greater. The entire universe could be a self-sustaining wormhole, a cosmic bridge folded in higher dimensions. Our Big Bang might have been an exit event from another collapsing cosmos, a birth through the throat of an older one. If so, the builders were not aliens, but nature itself, endlessly cycling creation through destruction. Every black hole becomes a seed, every collapse a new beginning. Still, the dream of building our own remains. Physicists imagine enormous particle colliders, larger than entire solar systems, generating the energy densities necessary to tear space-time gently. Quantum computers might one day calculate the precise feedback loops required to stabilize curvature with artificial negative energy. Nanostructures woven from light and plasma might shape gravitational fields like clay. Each idea feels fantastical, but so did flight. So did splitting the atom. So did touching the moon. Yet the deeper we explore, the more philosophical the question becomes. Should we? What right does any intelligence have to rewire reality, to create shortcuts through existence itself, skipping the natural rhythms of distance and time? A wormhole is not a mere technology. It is an act of rebellion against separation. To build one is to declare that the universe's boundaries are negotiable. And if the universe has laws, such defiance may not go unpunished. Some physicists argue that chronology protection, a kind of cosmic immune response, would destroy any attempt to create paradoxes. The moment a wormhole threatens causality, quantum effects would destabilize it, collapsing the bridge before harm is done. It's as if the universe itself guards its own timeline, ensuring that no intelligence, however advanced, can rewrite its past. Others think differently. They believe that causality is not absolute, that time is elastic, capable of folding like space does. In such a framework, wormhole creation is not violation, but continuation, an extension of the universe's own geometry. To them, building a wormhole is no different than growing a tree, provided you understand the soil. In the end, the builders of the impossible are not defined by what they can do, but by what they dare to risk. Whether human or alien, their work demands faith, in physics, in beauty, in the idea that knowledge itself is worth the danger. Because the truth is simple. To open a wormhole is to confront the unknown in its purest form. To stare into that dark mouth and say, "Let's see what happens." Maybe that's how it always begins. With curiosity so deep it overrides fear. With the realization that every barrier in nature is also an invitation. And perhaps, someday, when our descendants gaze at the distorted light of a distant galaxy and notice the faint pulse of a repeating anomaly, a rhythm that shouldn't exist, they'll know what they're looking at. Not a star, not a signal, but a bridge. Built by those who once looked at the universe's silence and refused to believe it was unbreakable. There's a moment, just before you cross, when silence becomes total. Not the silence of absence, but of compression. Every vibration, every thought, every heartbeat folded into the same infinitesimal now. You are no longer falling. You are being rewritten. The boundary of the wormhole is not a wall, but an equation. One that decides what of you gets to exist on the other side. Your atoms, your memories, your sense of self, all of it becomes data, carried by geometry itself. And here begins the deepest question of all. If your body and mind can be disassembled, scattered through curved space-time, and then reassembled elsewhere, would the result still be you? Physics tries to answer without flinching. It says identity is information. The arrangement of atoms, the pattern of energy, the configuration of quantum states. If that information survives, so do you. But quantum mechanics complicates the story. It tells us that observation shapes reality, that coherence is fragile, that information, once lost to decoherence, cannot be perfectly restored. To cross a wormhole would be to subject yourself to an environment of unimaginable turbulence, where quantum states unravel like smoke in a hurricane. The gravity gradients alone could cause phase shifts in molecular bonds, distort wave functions, scramble the neural map that defines memory. Your consciousness is not a singular thing. It is a cascade of interactions, electrical, chemical, and quantum, all delicately synchronized. What happens when time itself is stretched and twisted? Would the signals in your neurons remain in phase, or would they desynchronize, spreading out into statistical noise? In classical terms, the answer is fatal. You would be torn apart. In quantum terms, perhaps not. Information, according to modern physics, can never truly be destroyed. Even black holes, once thought to erase all data, are now believed to encode it on their event horizons in subtle patterns of radiation. This is the essence of the holographic principle. The idea that everything inside a region of space is represented on its boundary, like a three-dimensional image projected from a two-dimensional film. So maybe, as you pass through the wormhole, you are recorded, transcribed onto the surface of space-time itself. Every atom, every bit of quantum information preserved as a holographic imprint. The traveler becomes a pattern written on the skin of reality, sliding across dimensions like a shadow. If the wormhole's geometry allows, that pattern could then be reprojected elsewhere, reassembled, reanimated. To outside observers, it would seem like teleportation. To the traveler, perhaps only a blink. But what if consciousness doesn't blink? It breaks. Because information may be preserved, but continuity might not. The you who emerges may have the same memories, the same thoughts, the same voice, but the original was erased in transit. From the inside, there's no distinction. Continuity feels seamless. But philosophically, the question lingers like an echo. If a perfect copy wakes up believing it's you, did you survive? Or did the universe simply fool itself into thinking you did? It's the same question that haunts teleportation paradoxes and digital immortality. We imagine ourselves as entities, but perhaps we're only processes, ongoing patterns of information that can be paused, rearranged, or restarted. If so, a wormhole is not a passage at all. It's a reboot. What emerges is not who entered, but who is computed next. The equation suggests that the wormhole could, in theory, preserve quantum coherence if the geometry is smooth enough. Exotic matter could prevent tidal forces from tearing wave functions apart, maintaining a continuous flow of space-time around the traveler. The journey would feel strange. Time dilation, stretching moments into eternities, clocks melting into paradoxes, but survivable. Yet even in this gentlest scenario, consciousness is tested. Because time itself behaves differently inside the throat, causality becomes unreliable. Your thoughts might not follow one another in sequence. Cause and effect blur. You could remember the end before the beginning, think a thought that triggers its own cause. In that state, self-awareness might dissolve, not from damage, but from perspective. Imagine being able to see your own life from outside of time. Every moment, past, present, and future, visible at once, not as a story, but as a sculpture. What would you mean in such a context? A sequence loses meaning when all its points coexist. You would not think. You would be thought. And maybe that's what crossing a wormhole truly feels like. The end of linear selfhood, the merging of the observer with the observed. Consciousness stretched so thin across dimensions that it stops being a location and becomes a pattern in space-time's memory. This is where philosophy collides with physics. If the universe is holographic and consciousness emerges from physical information, then what we call self is a localized expression of something universal. Perhaps your awareness is already non-local, spread across time and space, only appearing continuous because perception stitches it together. The wormhole would simply reveal that truth brutally. Inside it, you'd experience what the universe experiences every moment, being everywhere at once. But could awareness endure that? Could the fragile symmetry that holds identity together survive infinite simultaneity? Would your memories still be yours if they existed all at once, untethered from sequence or causation? Or would you dissolve into the sum total of all possibilities? Every version of you, across every quantum branch, merging into a single, radiant now. Physicists debate whether information passing through a wormhole can remain entangled. The EREPR conjecture, Einstein-Rosen equals Einstein-Podolsky-Rosen, suggests that every entangled particle pair is connected by a tiny wormhole. If true, then crossing a macroscopic wormhole would mean traveling through the same network that underlies entanglement itself. You wouldn't merely move through space. You would move through the fabric of correlation, the architecture of connectedness. Consciousness, then, might not need to survive the journey. It might simply continue through a different configuration of the same network. You'd emerge not as a reassembled pattern, but as a redistributed one, your awareness unfolding elsewhere, like a song carried on a new wavelength. And yet, the fear persists, because while the math may preserve you, the experience may not. For the traveler, the moment of crossing could feel like death. Every coordinate of your body stretched across infinity, every neuron frozen in a paradox of time, every signal delayed until cause and effect no longer know who comes first. Perhaps consciousness would experience a kind of eternal stillness, a liminal pause between what was and what will be, a single instant that lasts forever. There's poetry in that image, a human soul suspended between universes, light streaming through its dissolving edges, thoughts unraveling into equations. But there's terror, too. Because if identity is continuity, and continuity breaks, then no one truly returns. Every explorer who dares to cross becomes a lineage of ghosts, each iteration remembering the last, never realizing it's not the original. The universe, in its indifference, keeps only the pattern. Yet maybe that's what we've always been: echoes. The atoms in your body are borrowed, recycled from ancient stars. The photons striking your eyes now began their journey before human language existed. You are a collection of processes older than yourself, pretending to be one thing. The wormhole simply makes that truth undeniable. It reveals that there was never one you to begin with, only the illusion of persistence, held together by memory and time. Still, we imagine the crossing. We can't help it. We picture the traveler as a silhouette against the glowing mouth of the tunnel, stepping forward with trembling resolve. As they enter, their body begins to shimmer, scattering into particles of light. The structure of space-time peels them apart gently, not in violence but in translation. They become data, encoded in curvature, whispering through the geometry like a message through a fiber of the cosmos. Somewhere, light years or dimensions away, the message reassembles. The particles reform. The traveler opens their eyes. Everything feels the same. The body obeys. The memories are intact. The stars outside are new, but the mind inside insists. I made it. But physics smiles quietly. Did you? Or did the universe just rebuild you from the pattern it kept? This question haunts every version of the traveler's tale. The body may arrive. The mind may awaken. But continuity, the thread that binds identity across time, might not survive the journey. If consciousness depends on unbroken sequence, then crossing a wormhole is suicide disguised as discovery. But if consciousness is pattern, if what matters is the preservation of structure, not sequence, then perhaps the traveler does survive. Perhaps they transcend. In that case, death and travel become the same thing. Transferences of information through different states of geometry. To die is to move through a wormhole too narrow for matter, but wide enough for meaning. To live again is to emerge on the other side, unaware that the passage ever occurred. And maybe that is the final truth the wormhole offers. That consciousness itself is a bridge, a wormhole made of thought, connecting one moment of awareness to the next. That every breath, every heartbeat, every blink is another crossing between infinities. The traveler enters the wormhole once, but in truth, we have been traveling it all along. Through time, through memory, through the fragile architecture of being. Somewhere in the endless curvature of the cosmos, light bends back upon itself and glimpses what it once was. A reflection, a thought, a human being who wanted to know what was inside the impossible. And in that reflection, perhaps it sees us, not as we are, but as we're becoming. Patterns of consciousness folded into the fabric of the universe, endlessly crossing from one side of existence to the other. echoes traveling forever through the wormhole of being, chasing the memory of themselves through the infinite mirror of time. What if the other side isn't a place at all? What if it's a state, a reflection of the universe gazing back at itself through the curve of time? Every theory begins with that simple temptation, to imagine what lies beyond the throat. We've fallen, endured, dissolved, and perhaps been rewritten. But now the horizon opens again, and the impossible question waits. What kind of cosmos receives the traveler who crosses through a wormhole? Einstein and Rosen's original bridge connected two regions of the same universe. Yet later theories dared to go further. Some proposed that the tunnel might not just bend space, but branch reality itself. That on the other side of a wormhole lies not another corner of the same cosmos, but another cosmos entirely. An alternate universe with its own laws, constants, and history. In this view, wormholes are the arteries of a multiverse, channels through which universes exchange matter, energy, or even meaning. To visualize it, imagine a galaxy spiraling in collapse. Deep within its heart, a black hole devours everything: light, dust, and time. Its singularity compresses matter into infinity. But according to the equations of general relativity, that singularity could have a twin, a white hole. A white hole is the mirror opposite of a black hole, where nothing can enter, only escape. Where black holes swallow, white holes erupt, ejecting matter and energy into new space. Now imagine if the two were connected. The death of one universe feeding the birth of another. A wormhole, then, would not merely link distant places, but moments of cosmic reincarnation. Every black hole might be a womb, every white hole a cry of new creation. The universe could be eternally self-sustaining, collapsing and exhaling, birthing new realities from its own decay. The multiverse becomes not a collection of separate worlds, but a living organism, recycling its energy through wormhole veins. This is not just poetic speculation. Theoretical models like the Einstein-Cartan theory and loop quantum gravity suggest that the singularity at a black hole's center may not be a true point of infinite density, but a bridge, a bounce. In these frameworks, the collapse of space-time reaches a minimum scale, then rebounds, creating a new expanding universe. The constants of physics could shift slightly, giving birth to universes with different laws. Perhaps our own Big Bang was such a rebound, a burst of light emerging from the collapse of another universe long forgotten. If that's true, then wormholes are not rare accidents. They are the reproductive organs of reality, each one a transition from one cosmos to the next, a passage not of travelers, but of universes themselves. We would not be observers of the bridge, but children born of it. And yet, the geometry hides deeper paradoxes. If wormholes connect universes, what becomes of causality? Can an event in one universe ripple into another, creating echoes across dimensions? Could gravity itself leak between worlds, subtly shaping the structure of our cosmos? Some physicists have speculated that the mysterious force we call dark matter, so abundant, yet invisible, might be the gravitational imprint of mass from parallel universes, bleeding through wormhole connections we cannot see. In that sense, the other side may not be elsewhere. It may already be here, invisibly intertwined with our own. Perhaps every empty space you see is not empty at all, but a holographic overlap where countless realities coexist, separated only by phase. Quantum cosmology takes this further. In some interpretations of the Wheeler-DeWitt equation, the universe as a whole has no single timeline. It exists in a superposition of all possible histories, each branching from quantum fluctuations at the smallest scales. Wormholes could be the threads binding these histories together. Tunnels not through space, but through possibility itself. Each crossing could connect one version of the universe to another, linking what did happen to what could have happened. So maybe to travel through a wormhole is not to go somewhere, but to become something else. You don't move through distance. You move through probability. You emerge not where you intended, but as who you might have been. If that sounds like philosophy disguised as physics, that's because at this edge of knowledge, the two merge. Our instruments cannot probe such depths. Our math can only gesture. What remains is wonder. The poetic instinct that perhaps existence itself is recursive, folding back upon its own reflection. Some cosmologists imagine that wormholes connect not only different universes, but different epochs of the same one. A tunnel might link the past and future of our cosmos, allowing information, or even matter, to loop through cosmic time. If such wormholes exist naturally, they could explain one of the universe's greatest mysteries: its extraordinary uniformity. Why does every region of the cosmos, separated by light years, share the same temperature and density? One possible answer: before the Big Bang cooled, wormholes may have knitted space into a single connected whole, equalizing it before distance ever mattered. But let's step back from equations for a moment and consider the deeper implication. If wormholes connect times, universes, and realities, then the other side is not a singular destination. It is the infinity of all destinations. It's not a place waiting to be reached, but a spectrum of existence waiting to be realized. The traveler who crosses does not arrive in another world. They awaken to the fact that there are many, and that they themselves were never confined to just one. Philosophers might call this the realm of being itself, the space where existence differentiates into all possible forms. In that sense, a wormhole is not just a tunnel between universes, but a threshold between modes of existence. Matter to energy, form to meaning, self to infinity. On the other side of such a passage, language collapses. You cannot say there because there ceases to contrast with here. You cannot say other because otherness dissolves. You face the mirror of creation and realize the reflection is you. Imagine it. You emerge through the glowing mouth of the tunnel. Before you stretches not a star field but a luminous expanse of geometry. Space itself in bloom. The laws of physics are rewritten in light. Gravity hums like a slow pulse. Particles weave patterns that resemble thought. Time unfolds sideways, like a ribbon of endless present. Galaxies spiral in pairs, each a reflection of the other, twin mirrors whispering across eternity. You have not reached another universe. You have entered the architecture of universes. If you could look back, you'd see your origin fading into abstraction. The universe you came from shrinks to a single point, a seed trembling on the edge of memory. Ahead lies not one reality, but layers upon layers. Worlds of different constants, different geometries, different symmetries of meaning. Some are blinding with order, others pulse with chaos. All are expressions of the same cosmic imagination, dreaming itself into every possible shape. Some physicists have speculated about universes where gravity repels, where light curves inward instead of outward, where time runs in reverse. Others imagine mirror realities where matter is replaced by antimatter, or where the arrow of entropy points the opposite way, where the future is our past seen backward. Perhaps in one such realm, there are beings descending their own wormholes, asking the same question we do now. What lies beyond ours? Maybe that's the secret symmetry of all existence, that curiosity itself is the connective tissue of the multiverse. Each intelligence, each awareness, each moment of wonder creates a bridge between realities. The act of asking is the act of connecting. If that is true, then wormholes are not built. They are realized. They emerge wherever consciousness dares to question its own limits. Every thought that reaches beyond itself becomes a fold in the fabric of reality, a subtle connection between what is known and what is yet to be. So what if the universe on the other side isn't foreign, but familiar? What if it's the inner reflection of the same cosmic mind, the universe thinking itself through us? Perhaps each wormhole is a neuron in that greater consciousness, firing across infinite space-time, transmitting the signal of self-awareness through the void. And perhaps, when we dream of crossing one, what we're really dreaming of is union, of rejoining the totality that once divided itself into stars, galaxies, and souls, just to know itself better. Physics calls this speculation. Philosophy calls it mysticism. But to the universe, maybe there's no distinction. A wormhole might not care whether it connects space-time or consciousness. It might see both as coordinates on the same map. The ultimate realization, then, is not that wormholes link universes, but that existence itself is a wormhole, a continuous folding of being, through which awareness travels endlessly, never reaching an end because the journey is the purpose. And maybe, just maybe, this is how universes reproduce meaning. Each one gives birth to another, not through explosion, but through recognition. Through the moment when it looks inward, finds curiosity, and decides to see what lies beyond. Every question becomes a bridge, every act of wonder, a doorway. So perhaps the traveler's journey never ends because the traveler never truly leaves. They step through one reality only to find another reflection waiting. They ask what lies beyond the universe, and the universe responds by creating a new one, just so the question can continue to exist. If wormholes are real, then they are not escape routes from the cosmos. They are expressions of it. They show us that creation and destruction, here and beyond, are one continuous act. On the other side of the wormhole, there is not another universe waiting for discovery. There is the same universe, seen from a deeper dimension, the mirror side of being, where every possibility already exists, waiting for consciousness to pass through and bring it to life. And maybe that's the final secret, that the universe does not end anywhere. It only folds. Each fold births another cosmos. Each question opens another passage. Each act of looking reveals another reflection. And somewhere, in the infinite hall of mirrors that is reality, the universe looks back through all its folds and wonders the same thing we do. What lies beyond everything? And in that wondering, another wormhole is born. There is a silence deeper than the vacuum between galaxies, the silence that falls when knowledge reaches its own edge. The wormhole stands as that edge, a riddle shaped by the universe itself. To look into it is to gaze into a mirror so pure that even thought begins to bend. Every question we ask pulls us closer to its mouth. Every attempt to understand draws us toward collapse. Because here, at the boundary of the possible, the paradox becomes complete. To see inside a wormhole may mean becoming part of it. The equations whisper their warning. A wormhole, in theory, is exquisitely balanced. An impossible corridor suspended between gravity's hunger and geometry's resistance. Introduce even the smallest disturbance. A particle of light, a single photon, and the symmetry breaks. The throat collapses. The bridge evaporates. Observation itself destroys the structure it seeks to reveal. It's not poetic metaphor. It's physics. The act of measuring the unmeasurable destabilizes the very conditions that made it exist. In quantum mechanics, this is a familiar cruelty. Every wave function collapses under scrutiny. Every possibility narrows to one. But on the scale of wormholes, the consequence is cosmic. To witness the interior is to unmake it. The moment consciousness enters the unknown ceases to be. It's as though the universe protects its deepest truths, not by hiding them, but by ensuring that to touch them is to end them. And yet, this is the story of humanity. We are a species defined by trespass, by the need to look where we shouldn't. We cracked the atom knowing it could end us. We mapped the genome before understanding what it meant to rewrite life. We send probes into the night, chasing whispers from stars that will never hear us. Our greatest achievements always carry the scent of forbidden knowledge. The wormhole is the ultimate version of that temptation, a door through which understanding itself may never return. Imagine the experiment. Instruments primed, telescopes aligned, equations complete. The moment the probe enters the mouth, the data stream explodes into noise. Sensors fail. Space folds. The feed goes silent. We try again, refine the models, adjust the variables, but the outcome repeats. Every attempt to observe the interior alters its geometry. The observer becomes part of the observed, the line between cause and consequence blurring until neither can stand. Perhaps this is not failure, but law. Perhaps the wormhole exists only as long as no one tries to know it. Like a secret sustained by silence. Its stability depends on ignorance. Once awareness arrives, symmetry collapses. The mystery survives because it devours all who chase it. But isn't that the nature of consciousness itself? The more we examine the mind, the less solid it becomes. Neuroscience finds no central self, only a network of processes, each aware of the others, none in command. Like a wormhole, the mind is a bridge between perception and reality, a tunnel through which experience flows. And just like the wormhole, it cannot be fully known from within. The observer and the observed are the same. The act of awareness alters the thing being aware. To look inward is to fall endlessly through layers of selfhood. Memory observing thought, thought observing feeling, feeling observing memory again. There is no final witness, no stable ground, only recursion. Consciousness exploring itself, chasing its own reflection through the corridors of time. Perhaps that is the true meaning of the wormhole. Not a cosmic passage, but an ontological one, a symbol for the mind trying to comprehend the infinite while being part of it. Science calls it instability. Philosophy calls it paradox. Mysticism calls it unity. They all describe the same collapse, the moment when subject and object dissolve into one another. To stand before a wormhole is to confront the same truth that haunts every act of awareness. The more deeply you gaze, the more the distinction between you and it fades. In the end, you are not looking at the universe. The universe is looking at itself, through you. There's a haunting symmetry in that thought. The equations describing a wormhole mirror, the equations describing entanglement, and entanglement mirrors the structure of thought itself. In all cases, separation is an illusion sustained by perspective. The wormhole joins two regions of space-time. Consciousness joins two regions of being, the known and the knower. When you collapse one, you collapse the other. If we ever did build such a bridge, perhaps the greatest danger wouldn't be physical annihilation, but metaphysical revelation. Because what if, upon crossing, we discovered that there was never another side? That the wormhole was never a passage, but a reflection? That all the stars, all the universes we thought lay beyond were projections from within, folded outward by the curvature of mind? What then? What happens when exploration leads not outward, but inward? When the final frontier is not space, but consciousness realizing it has been the explorer and the cosmos all along? Maybe that's why the universe guards its secrets with collapse, because to truly know them would erase the distance between observer and observed, between question and answer. And once that distance disappears, so does meaning. The wormhole cannot survive being known, just as mystery cannot survive certainty. To look too closely is to end the story. Still, humanity will keep looking. It's in our nature to chase horizons even when we know they dissolve at the touch. The same curiosity that fuels science fuels faith. The hunger to know what cannot be known, to pierce the veil between finite and infinite. Every telescope, every particle collider, every thought experiment is a small wormhole, a tear in ignorance through which light briefly passes before space closes again. Perhaps that is enough. Perhaps the point is not to reach the other side, but to keep folding space with our questions. Each act of wonder shapes the universe, however slightly, bending its geometry toward awareness. We are the wormhole's paradox incarnate. Creatures made of stardust, trying to comprehend the stars, collapsing every mystery we touch, yet leaving new ones in the wake of our curiosity. In the end, the wormhole becomes less a structure and more a metaphor, the image of consciousness seeking itself across the void. To peer inside is to risk disappearance, but to refuse is to remain blind. Somewhere between knowing and unknowing lies the delicate balance that keeps existence from unraveling. So we stand at the edge, as we always have, our telescopes trembling, our minds aflame. The universe folds into an eye, light curves into thought. We look into the darkness, and the darkness looks back, not with malice, but recognition, because in that reflection it sees what we have become, the question that will not stop asking. Maybe that is the true function of a wormhole, not to transport us across galaxies, but to remind us that knowledge itself is a form of gravity. It pulls us inward, deeper, toward the singularity of understanding where everything we know and everything we are collapses into one, and in that collapse, brief, blinding, eternal, the universe knows itself again. The real wormhole was never out there. It was the space between what we know and what we can imagine. For centuries, we've looked into the night sky and mistaken distance for destiny. We built telescopes, equations, and dreams, each one a bridge to the unreachable. We believed that if we could just see far enough, measure precisely enough, think deeply enough, we might finally glimpse what lies beyond everything. But perhaps the truth was never about distance at all. Perhaps the frontier we've been chasing has always been internal, the fold between wonder and understanding. Between mystery and meaning, wormholes began as equations, mathematical whispers of symmetry buried in Einstein's geometry. But over time, they became something more. A mirror. In their impossible curvature, we see our own reflection, the same longing to connect, the same defiance of separation, the same hunger to outpace time. They remind us that curiosity itself is a bridge, and that every question we ask carves another tunnel through the unknown. We imagined falling into one, a descent through liquid space, light twisting into ribbons, time unraveling into paradox. We imagined emerging somewhere else, another galaxy, another universe, another version of ourselves. Yet after all the theories, the paradoxes, the equations, one truth lingers. Maybe the journey was never about arrival. Maybe wormholes are not shortcuts through space, but metaphors for the way consciousness travels, forever folding in on itself, forever seeking what lies beyond the next horizon of thought. Science gave us the framework. Curvature, energy, exotic matter. But meaning gave us the question, why do we need to know? Why do we keep reaching toward the impossible, even when the impossible stares back? The answer may lie in the same force that shapes every galaxy, the tension between gravity and light, between falling inward and breaking free. Knowledge pulls us forward. Mystery holds us in orbit. The universe expands through our curiosity, and perhaps it dreams through our asking. Imagine, then, that somewhere in the deep black between galaxies, a wormhole really does exist. Silent, invisible, waiting, not as a passage to elsewhere, but as a symbol written into the architecture of reality. A reminder that connection is the universe's native language, that even across the gulfs of distance and difference, there are hidden paths where everything touches everything else. Maybe that's what it means to exist, to be a wormhole ourselves. Every thought we have folds past and future into one. Every act of awareness connects the finite and the infinite. Every human life is a bridge between ignorance and understanding, born from one unknown and returning to another. And perhaps that's why the mystery never ends. Because the moment we think we've reached the other side, we realize the tunnel only opens deeper inward. We look into the cosmos and see ourselves reflected in its design, not as masters, not as intruders, but as participants in its endless recursion. The universe isn't something we stand apart from. It is something that happens through us. The light we chase has always been our own, so we end where we began, with a question. What lies beyond the wormhole? Another universe? Another truth? Another version of being? Maybe. Or maybe the answer isn't waiting in the stars, but in the act of looking itself, the search, the awe, the unending curiosity. These are the real bridges between worlds. In the final silence, you can almost hear it. Light collapsing into a heartbeat, a tunnel opening into an eye, the universe folding into thought. Perhaps that was the purpose all along. Perhaps the universe built wormholes so it could dream of itself.